Okay, so let's in the first weeks we have studied about that place of articulation, speech acoustics, and overview of signal processing. Let's start the new topics, that uniform tube modeling of speech production. That what is the purpose of that whole course for speech processing is that we should know how the human speech is produced. Okay. After knowing that, can I able to mathematically model that human speech production? That is our motto. If I know the mathematical model of speech production system, then studying the system property, we can know what kind of speech property we should look for in the acoustic signal. Okay. So, our motto is to develop a mathematical model of human speech production systems. Now, if you see that we have said that the human speech production system has a two part. One is the glottal vibration, that glottist is the source of vibration, and that sound or vibration pass through the vocal cavity, or you can that oral cavity and nasal cavity, and produce the different kind of sound depending on the tube structure or the cavity structure. Okay. Now, we want to develop, if the glottist is produced sound, how can I model this tube model, so that I can say, if I am able to design the mathematical model of the human vocal cord system, then I changing the parameters, I can produce the speech. Or what I know, that if I know the exact model or approximate model of the human speech production system, I know the model property. So, I deriving the model property, I can understand what kind of signal processing I should apply on human speech, so that I can know exactly what is happening in here. Okay. Now, if I want to model it, the complexity is that human speech production model is not a simple single tube. If I have a, if you see in high secondary also you have studied that there is a single tube, if this end is closed and a sound is generated here, you know what kind of frequency you accept, what kind of sound you expect from the sound, that depends on the L of the length of the tube. But in human vocal tract, this area of the tube in here it is fixed for a rigid tube, but human this area is not same throughout the tube. So, that area may be look like this, area maybe this is the upper cavity, let us lips, then started, this is the upper cavity which is almost fixed, and if you see the lower cavity, the tongue of the tip and then back tongue of the tip, and like this way. Now, if you see, depending on the different sound production system, the structure, the cross sectional area of the different portion of the cavity for different sound is different. So, you can say there is two kind of variation. When I produce the speech signal is changing along the time. That means, the constriction of the tube or structure of the tube is changing along the time, and also for a particular time, let us produce for this time t 1, the structure, the cross sectional area of the tube in all section is not same. Okay. So, two complexity, one is that cross sectional area of the tube is not equal in every length. So, if I say this is the glottist or this is the vocal cord, so this is the x equal to 0 and this is at the lip. If you see this is the, if this is the lip or if the dental and then there is a lip, if I say there is a lip, so and at lip let us x equal to L. So, length of the tube is L, okay. But throughout the length here cross sectional area is same, if it is A and here it is also A. Now, in here it is different, here it is different, here it is different, let us here it is different, here it is different, here it is different. So, different kind of cross sectional area is there. Now, once I produce caw, maybe the back of the tongue touches the upper cavity. When I produce paw, lip is touches close together, main cavity structure will be different. So, I can say for different sound, or when you continuously produce the different kind of sound, the cavity structures is changing with respect to time also. Okay. Now, we could not consider that, let us we considering that at for a particular sound with fixed cavity structure is there. Okay, that is okay. Another simplification we done. Let us think the whole human vocal system is nothing but a single cavity, single tube or single tube whose cross sectional area is fixed A. So, I say throughout the glottis or vocal cords to mouth, throughout the whole system, the cavity is uniform or given the tube is uniform and it has a cross sectional area A. So, this is called uniform tube modeling. Okay. Now, let us I consider it is uniform. Then we say cross sectional area is A. Even it is uniform, then also the walls of the cavity is not rigid. These walls are not rigid. If it is not rigid, then if the air pressure increases, the area cross sectional area may change. So, this is less vocal cord x equal to 0 and this is lip side x equal to L. So, if the walls are not rigid, if this tube is not rigid wall, then when the air pressure is passing through, the tube walls will be the cross sectional area of the tube will be changed because the wall will be deformed. Okay. Now, neglect that part also. They do not consider that part. So, I am not considering, we said neglect that part. Let us the wall consider walls are rigid. Next one is that there may be a thermal loss, there may be a viscous loss, there may be a friction loss. Let us consider that loss also not there. So, we simplify that human vocal tract is nothing but a single tube whose cross sectional area is constant A. There is no friction loss, there is no viscous loss, there is no thermal conduction. Then try to derive the equation of this human vocal tract. Okay. So, uniform tube model. So, how do we derive that vocal tract equation? So, if it is a system, if you studied the electrical system signals and system, if I have a system, if I apply a input, let input is x n, let us I consider x n and output is y n, then transfer function if it is h n, then we say h n is nothing but a y n divided by x n. Okay. So, we know how the sound is propagated, input sound in here which is input is provided by the glottis or vocal cords. After vibrating it injects the particle velocity and that particles will propagated along here and radiated from the mouth. So, I have to know how the wave is sound wave is propagated along this tube. Okay. Along this tube. Now, you have already studied that wave equation, you know the wave propagation equation. So, what is tell that if I produce a sound, can I mathematically express the, so if I produce a sound is propagated in the medium with a condensation and relaxation way. Can I develop a mathematical equation how that pressure wave is propagated from one point to another point? That is the wave equation. Okay. Now, considering that amplitude of the pressure, if I say the wave is propagated linearly, then we say linear wave equation. Here I am saying the amplitude of the sound is not that enough that propagation become non-linear. So, I said amplitude is less within the limit and sound is propagated linearly in the medium and medium is also homogeneous. Then we can derive the linear wave equation. Okay. Similarly, here also we try to derive the linear wave equation, how the wave is propagated along the tube. Let us try to do that. So, how do we do it? Let us consider a single cube in here. Okay. So, pressure is, so I can say this is a piston kind of things which produce the pressure in the air, and that pressure is propagated along this tube. So, if I consider a single cubicle, let us I draw the picture neatly, let us I consider a single cubicle inside the tube whose dimension, let us consider the dimension are, this is less del x, del y, let us del z, del x, del y, del z. So, let us volume is V is equal to del x, del y, del z. Okay. So, this is the volume and this is the cube. A small cube inside the tube I am considering. Okay. Now, if I see there is a pressure wall in here. So, the pressure is applied in here, which is P. Let us I am saying. So, if it is if there is no pressure is applied by the piston, then inside the tube it is the atmospheric pressure. Atmospheric pressure means, atmospheric pressure is what? Let us that is the average pressure or atmospheric pressure, what that is P 0. Once the piston apply a force pressure, then that is P. So, change pressure is a function of the piston may apply a force in here. How the pressure will propagate it, that depends on the position where I am taking the position, that x equal to 0 to L. So, this depend on the position and time. So, change of pressure, the pressure change is a function of position and time. Now, if you see, if I apply a pressure, okay, then what will happen? The particle will start moving inside the tube, but average velocity of the particle is 0, because medium is homogeneous. When sound wave is propagated, medium does not change. So, that means the particle velocity is exist, but the average particle velocity is 0. Okay. So, let the particle velocity is v, small v, and that also function of x and t. Okay. Now, if it is a pressure wave, condensation and relaxation, condensation and relaxation. So, density is also changed. So, density is also function of x and t. So, in equilibrium I say medium is homogeneous. Okay. So, I have already said some assumption I have taken, that amplitude of the pressure wave is within the limit where the sound is transmitted linearly. That is why we call this linear wave equation. Okay. Now, if it is linear wave equation, then how do I derive that wave equation? So, what do you understand by wave equation? That means, I want to know how the pressure from x equal to 0 is propagated along the tube. Let us at x equal to L, I want to know what is the pressure. So, I want to know the pressure movement equation, mathematical equation of the change of pressure with respect to position and time, and also mathematical equation for particle velocity with respect to position and time, and also the relation between the pressure wave, pressure with respect to position and time with the particle velocity with position and time. So, that I want to know, that is I want to know the derive those equation. Okay. So, for deriving those equation, you already studied it maybe in acoustics or in wave equation derivation in first year physics. We consider three principles of physics. One is called Newton's second law of motion, second is called gas law or thermodynamics, and another one is conservation of mass. Think about, if I apply a pressure in this plane, okay, so change of pressure, and the pressure is exist in this plane is let us P 2, this is P 1, then I can say the pressure difference. So, pressure, if P1 is the pressure, then I know the pressure into area, let us A1 is the area and this is also A1. So, pressure into A1 give me the force, let us this is F1 which is acting on this plane, and force which is exiting from this end is nothing but a P2 A1. So, difference of force is the cause of the motion of this block. Okay. So, I can say Newton's second law of motion, the force equal to mass into acceleration. So, the force, resultant force cause an acceleration of the cube which is nothing but a force equal to mass into acceleration. Okay. Mass of the cube into acceleration. Okay. Now, second law said the gas law of thermodynamics related pressure, volume and temperature under the adiabatic condition. So, what is the meaning? If I apply a pressure on this tube, this block, suppose there is a block, I apply one plane, one pressure is applied. So, if I apply a pressure, the volume will be changed. If the volume is changed, mass would be changed, but mass will not change. It increase the density due to the conservation of mass, mass will remain same, density will be changed. Volume will be changed because the cube will be deformed due to the applied pressure. Okay. So, although if the pressure is increases, the volume is decreases, but mass of the cube will be remain same, and this is an adiabatic condition. So, I say there is a when the sound wave is propagated, there is a no conduction of heat. Okay. Now, if that is the theory, so using these three law we have to derive the wave equation. So, again I can if you see the slides, the assumption I have said medium is homogeneous, pressure change across the small distance, there is no frictions in air particle velocity is small, sound is adiabatic. Okay. Now, if I want to derive that equation, what I will do? This is P1. So, I can say P1 is nothing but a P1 acting on the pressure. So, it is P of x t, not capital P, small p. Okay. What is P2? Is nothing but a, since del x is the length along the x direction. So, it is nothing but a small p x plus del x t. Okay. What is p of x plus del x t? Is nothing but a p of x t minus p of x t and plus change of pressure to for the dx distance. So, it is nothing but a del p by del x into del x. I said change of pressure is linear, I am not considering the non-linear term. Okay. This is the P1 and P2x. So, if I say P2 minus P1, which is nothing but a P of x, or I can say P1 minus P2 acting of pressure in P1, here it is P2. So, P1 minus P2 is nothing but a P of x t minus P of x plus del x t, which is nothing but a P of x t minus P of x t minus del p by del x into del x. Okay. Now, if I say what is the force acting on this plane multiply by the area. So, it is A1 multiply by A1. So, I can say the A1 is multiply. So, it is A1 is multiply. So, it is nothing but a A1 del p by del x into del x. So, what is A1? Is the cross sectional area of this area. So, this is nothing but a del z into del y. So, I can say it is nothing but a minus del p by del x into del x del y del z, because A1 is equal to del y into del z. Okay. So, I get the force. So, it is nothing but a force acting on the cube. So, force is equivalent to mass into acceleration, Newton's second law of motion. So, force is equal to mass into acceleration. So, what is force? Minus del p by del x into del x del y del z is equal to mass into acceleration. What is acceleration? Del v by dv by dt. Rate of change of particle velocity is the acceleration. So, I can say it is nothing but a m into dv dt. This v is the particle velocity. Okay. Now, if I say that, then what is dv dt is a total derivative that, and v is a function of x and t, v is a function of x and t. So, I can say dv dt is nothing but a del v by del t plus v into del v by del x. Okay or not? Del v by del x. Now, if I consider this term, this is a nonlinear term. If I drop this term, that okay, this term is if the v, the particle velocity is very small, particle velocity is less negligible. In that case, I can say that del dv by dt is nothing but a del v by del t. Okay. So, in that case, I can write minus del p by del x minus del p by del x is equal to m into del v by del t. Okay. What is m? M is nothing but a density into volume, which is this, that will be del x, del y, del z. Rho into volume. So, rho volume means del x, del y, del z into del v by dt. This will cancel. So, I can write minus del p by del x is equal to rho del v by del t. This is the equation number, wave equation number 1. Minus del p by del x is equal to rho into del v by del t. Okay. This is equation number 1. So, Newton's second law of motion. Now, I come to the gas law. What is gas law said? P v is equal to n r t. You know, n is moles of air, r is gas constant, T is the temperature in Kelvin. That is the gas law, adiabatic gas law, I can say. Or I can say P is equal to rho v divided by m into R T. Rho is the density, V is the volume, P V. V is the volume, m is the molecular weight of the air, and again R and T is there. So, if you see here, it is there. So, P v is equal to n R T and P v is equal to rho v by m into R T. Now, if I say then P is equal to, I can say rho v cancel, rho R T divided by m. Okay. Rho R T into m. Now, you know the c square or c is equal to bulk modulus divided by, that is you know. So, bulk modulus divided by density. So, instead of that I can write c is equal to root over of gamma R T by m, where I derive that. I am not deriving that one, c is equal to, so that you can derive from the pressure adiabatic condition, that if you require you can see the book and that is available, and I can next day I can also do that also if you required. Okay. You send me the mail if it is required, then I can derive that things also, or you can see that my another lecture in audio system engineering, derivation of linear wave equation. Okay. Now, if C is equal to, then I can say C square is equal to rho r t by gamma r t by m. What is gamma? Gamma is nothing but specific heat ratio. Okay. So, I can say from here I can say that P into gamma is equal to rho into C square. P into gamma is equal to rho into C square. Another way I can say P v to the power gamma is equal to, sorry. So, another way I can say P v to the power gamma is equal to constant. If I take the derivative with respect to t, d dt of P v to the power gamma is nothing but a 0. So, what is this? I can write v to the power gamma into del p by del t plus p gamma v to the power gamma minus 1 del v by del t. This v is volume, this v is capital V, which is volume, okay, minus del v into del t is equal to 0. I can do that. That is equal to 0. Now, if I say what is V? Volume is nothing but a into del x, cross sectional area into del x. So, cube, if you see the cube, volume of the cube is nothing but a y z plane cross sectional area del y into del z into del x. Okay. Now, if I say dV or if I say del V by del t is nothing but a into del x by del t, which is del V. Okay. If it is that, then I can write a into del V by del x into del x. I can write. Now, I put this one in here. So, what I get? V to the power gamma del p by del t plus p gamma v to the power gamma minus 1 into a into del x. What is a into del x? Into del v by del x. So, it is nothing but a v into del v by del x. So, I can write v into del v by del x. So, it is nothing but a v to the equal to 0. So, v to the power gamma into del p by del t plus rho gamma into p into v minus 1 into v to the power gamma del v by del x is equal to 0. Okay. So, this v is volume velocity and this capital V is the volume, because here I have said del x by del t is nothing but a particle velocity, particle velocity. So, this V is the particle velocity. Okay. So, I can say v to the power gamma is cancelled. So, I can say del p by del t is nothing but a rho into p del v by del x is equal to 0. Okay, I can say del p by del t is equal to minus rho p gamma p into del v by del x, which is nothing but a, I said pressure into gamma is equal to rho c square. So, I can say it is nothing but a minus rho c square del v by del x. Okay. So, I can write another wave equation. So, first wave equation was del p by del x is equal to minus rho into del v by del t, and here I get del p by del t is equal to minus rho c square del v by del x. Okay. Or another way I can write this one, same way, that I can write minus or minus del p by del x is equal to rho del v by del t, and del p minus del p by del t is equal to rho c square del v by del x. Okay. Now, if I want to know the pressure equation, so what I will do, let us this equation derive respect to del dx. So, del square p by del x square, let us minus, is equal to rho into del v by del t into 1 by del x. If I again do it in respect to t, minus del square p by del t square is equal to rho c square del v by del x into 1 by del t. So, if you see this side and this side, what is the difference? 1 by c square only, 1 by c square. If I multiply, so I can write minus del square p, or minus this side minus, this side minus. So, I can write del square p by del x square is nothing but a 1 by c square into del p square by del t square. Okay or not? Similarly, I can derive the same equation, which is nothing but a del square v volume particle velocity by del x square is nothing but a 1 by c square del square v by del t square. So, I can say this is the wave equation with this pressure wave equation, this is the particle velocity wave equation. Okay. So, I can say this is the wave equation with along when the wave is propagated along the x axis, but I have not considered the wave with the any particle velocity with the x, y and z direction. So, let us I say the wave is propagated along the x axis and there is a not other directional particle velocity. So, friction force is not there, viscosity loss is not there. So, nothing is there. Okay. Then this is my velocity pressure equation, this is my velocity equation. Okay. Now, what I know in the tube how the pressure wave is propagated. How the pressure wave is propagated I know in the tube. Now, I have to derive. So, pressure wave mathematical equation I know, but I do not know what is the solution of the P. So, I have to second order differential equation, I can solve that second order differential equation and find out the equation for P, okay, solution of the second order differential equation, and then try to find out what should be the transfer function of this vocal tract tube. Okay. So, next class we try to derive the transfer function of single tube. Okay. Thank you.